there's been a lot of stuff in the news recently around how these big companies are investing big dollars in Louisiana. Not kind of light on detail, but it raises a lot of really good questions. And instead of jumping directly into like the critical analysis of what it means to bring a $10 billion data center to Louisiana, it's kind of interesting to look at it from the point of view of how we can actually use that to win. And then also, like, what does it take to build a data center? What are the components that go into that? What is the infrastructure that's needed? What are the considerations that we should consider? And just to kind of educate everyone a little bit more in how data centers work. We're really lucky to have Michael McCoy here. I'll let Michael kind of introduce himself and talk about what he does. But this is, like all of the events that we do, this is an opportunity for us to have additional discussions after the fact, hopefully work towards real tangible solutions. Everything that the Let Alone Philosophers group works towards is a philosophy of action. So we've done things like we've raised over $200,000 for all sorts of great causes, from shrimp welfare to, or killing shrimps more humanely, I should say, instead of letting them suffocate, stunning them, so it could kill them more humanely. A dollar saves about 1,500 shrimp. We found. And two, we've done a lot of political action work in the city. We did a huge door-to-door get out the vote campaign. I think the only very pre-election door-to-door campaign that was done in the city. So all that to say, I want to frame this in the idea of a philosophy of action, of what are next steps, or really my only question and why I'm here at the end of this conversation. NOAI is trying to create working groups now. So to create specific working groups that we can then use to raise money, foster awareness, and eventually work towards NOAI presentations. This is kind of an experiment that we're doing right now. This is our second experiment. Our first experiment was based around art and trying to create an artist residency. 3 people showed up to that, and none of them were artists. So it was interesting, and I think it was a clear message. I don't know what that message is quite yet, but I'm really glad to see the crowd here. I think a few more people are going to be showing up. So without further ado, I can start fielding you questions, but I think you can kind of take it away.
Cool, yeah. Anyway, thanks for setting this up, Blake. Just came out of a random conversation on Slack last week. We put this together in no time at all. So yeah, this is really good. Anyway, yeah, I'm Michael McCoy, ADR Mike at GitHub. Some of y'all may have seen me before. I gave a talk earlier this year across the street about performance engineering on large distributed systems and things like that. But today here I'm going to talk a bit about data centers, and I've got a couple of slides. We're going to get through this, but broad overview. I've been working in tech in New Orleans for more than a decade now. I started out in oil and gas, working for Ion Geophysical out in Harahan, doing very low level coding stuff for them. Then I worked for GE Digital downtown for a bit, got laid off from there, and been at GitHub for 5.5 years now. Yeah, it has been that long. But I am an infrastructure engineer there. I've worked on basically everything related to the actual very low level physical infrastructure, networking, servers, data center design, performance engineering, all the way up and down the stack, up to the actual platform that runs all the Kubernetes and containers and all the little things that GitHub. Beyond that, I can't answer any questions about any of the works. Way too far away from that. But I'm going to swap this over here because we've got a couple of slides. This is the one without yeah, this is the generation in between. Put that back out. Okay. Gotcha. Let's see if it just works. There it is. Hey, look, it just works. how odd the computers just works in this different ways. Alright, so, I am going to kind of start a little bit, like I said, talking about just data centers, what they are, how they work, and then into this, like, how do we win kind of question. I don't know if you're any of my friends here. I have been saying for 2 years to anybody who would listen, I think we should build data centers in northern Louisiana. Because there's a lot of reasons, like, you know, anywhere with land and power, you can build data centers, but to be entirely honest, a lot of other places are out of land and power, or power, depending on what you're talking about. We're talking a little bit about the, like, power needs here, because even before AI came into the scene, like, this was already a crunch, right? Power, like, Northern Virginia has been out of power for a while. Seattle has been out of power for a while. Atlanta is running out of power. Dallas is running out of power. And, you know, Texas can't keep the lights on if it gets too hot or too cold. So, you know, vendors like consistency in their electrical grids. But again, before we go into it, let's talk a bit about it. This is actually a Microsoft AI data center right here. I'm pretty sure these are like Gen 7 or Gen 9 racks, which makes them like probably like a 2 or 3 year old, maybe a 4-year-old picture or something like that. But congratulations, you now know what a data center looks like. This is what all of them look like. But what do you need to make a data center? You need computers, you need a connection to whatever the rest of your network is, and you need power. And you need water. You need a lot of all of those things, a lot of power. To give you an idea, like each of these racks here, like, what is this? These are probably 25 kW per rack or something like that. Like, you're talking about like a lot of power per rack. Like your modern, like actual blade server is well above 1,000 watts. And AI servers are, you know, sometimes 10x that. We're talking about absurd amounts of power. All that these days is like, this is air cooled. Like, this actually gets to the limits, like the literal physical limits of how much you can air cool it, which is why anything you see with AI now is talking about like direct water cooling or something like that in any other racks. In fact, actually, like we explored, and our even most like just regular compute racks at GitHub, we explored doing water cooling because it's more efficient. And like I said, you're getting up against the physical limits at this point, which you can do with air cooling. So in most places, like they look something like this. If you've seen or heard any of the pictures of like, oh, we have a Connex box with computers and we landed in this place and we built all that together, that's kind of a model. If you've seen the render, and I didn't put it in this screenshot, but if you've seen the render of the supposed meta data center being built in North Louisiana, you'll see it's a bunch of warehouses that'll have something like this inside of them. And outside of it, there's a bunch of like smaller boxes, and these are kind of like the big, what we call hyperscalers build these big kind of like, it's all of the computers, all of the infrastructure, everything just in a box, you plop it on site, you plug it in, and you move on. That's a little bit different model, like really that is almost exclusive to your Googles, your Microsofts, and your Metas, and your AWSs. Nobody else builds a scale to like that kind of thing. So, yeah.
Are you saying like the warehouses are effectively the workhorse compute and the boxes next to it are like the orchestration kind of brains of it all?
Sometimes, right? It depends on your model, right? Like one thing that I know, like through what Meta has said about like these data centers is like it's a mix of what they do in these places.
But that's what you were kind of explaining that.
Yeah, exactly. Yeah. So like you know, there's also a little bit like, you know, there's a lot of like, you can see there's a lot of cabling here. Like I can tell you like there's thousands of fibers and these kinds of things. Like what they will do is like rather than like dropping these cabinets on site, sometimes they'll build them into boxes and they'll put a whole, you know, row of them down in one place. But that's not all they do. Like in particularly, like I want to talk about that in regards of like how many jobs this kind of thing can create, because like there are a lot of like on the ground jobs here. Like GitHub's data centers are, we're like tiny in comparison to this. We are like 15 megawatts. We're going to be 25 in like a year and a half. And we are on that kind of like power level, probably keeping like continuously employed like 10 or 15, 20 people depending on like the season in Virginia, just on that amount. And that like is cabling new things, repairing servers and all that kind of stuff, yes.
Yeah, I was just gonna ask that, like what is the breakdown of those 15 people?
There is like, most of it is going to be like cabling, like fiber work and things like that.
And do you rent cages or rooms or like run the entire DC?
We rent cages in colos, and that's one of the things when I get to kind of like the market and like what we would want to chase here. I'm going to talk about like the different tiers of these things to kind of make a point about like how we chase. But yeah, it's cages, we land racks and buildings like that. Like all the other hyperscalers do that too. Like Microsoft is constantly swapping in racks in and outside of this. Like I guarantee you 6 months after this picture was taken, this place was a mess to some degree, even in like very well managed data center. But okay, so kind of relevant to like our conversation and like what Meta is doing here. This is Northern Virginia. As I'm sure y'all don't know, like the internet lives in Northern Virginia around Dulles. Like there are hundreds of data centers up there for lots of historical reasons, but there's a lot of them. Like in this picture, there's a whole bunch of them. This is mostly Equinix facilities. If I remember correctly, either this site up here or one of these two ones, it's been like 2 years since I've been there, one of those has some GitHub in it. Just because I happened to like get up there and work on it. But sort of the point I wanted to make with this picture is these are big data centers. You see a lot of like transformers, everything's out here. Check it out way so everybody can see it. Like these more data centers, this is data center, this is data center. Everything in this picture is less than 2 gigawatts. This is less than what they want to build in North Louisiana.
Is that residential neighborhood, right?
Yes, it is. Yeah, that's like if you've ever like happened to flown in and out of Dulles before, you see a bunch of warehouses around there. It is a mix of data centers and Amazon services, like fulfillment warehouses. And there's a lot of them up there. I think there's like 100 some odd different buildings, and that it's a mix of wholesale and retail data centers as well as all of your big four in Amazon, Google, Microsoft, Meta. But I think it's kind of one thing that like there's not a lot of details out there, and I have like a little bit of things I can talk about that I've heard through the grapevine about this. Like, absent any other details, I can 100% know that this data center is fully going to be doing AI for Meta. Like 2 gigawatts is absurd. Like traditional, like each one of these buildings here is like on the order of 10 to like tens of megawatts. Like the biggest ones used to be 100 megawatt buildings. Campuses used to get toward like a gigawatt if you had a bunch of them. It's a pretty big data center that I want to build up here. So, before I kind of get into all the like numbers game, market stuff, what else? Anything else that I haven't covered people want to know about data centers, like basic operations, like all these kinds of things? Yeah.
Earlier when you said they're running out of power,
Yes.
what does that mean exactly? Because
It means they literally do not have enough either transmission or grid capacity to run the data centers. There's actually several projects in Northern Virginia and the Dallas area, as well as like they're even shutting data centers down in like the Seattle area because they literally do not have the grid capacity. They cannot get enough current through the transmission to run the data center like that.
does that mean because like they're not getting priority over residential, or is it?
There's just not enough.
It's the physics capacity.
Yeah,
of
we're
the
literally getting to
transmission.
like a physics capacity of this, right? Like we have actually, like this is actually a thing of like, when we're evaluating data center sites, like we're looking for like redundancy, like can you be served by more than 2 carriers so that if one of them loses power, you get to keep the other guy, and it's like, you're getting to the like, we would fill the air with transmission lines to get enough power into this place. Kind of place.
Massive infrastructure change.
Yes, yeah, and it's like, so you can imagine, like, once you start concentrating, like, all of this amount of stuff here, like, you're either digging underground to put really big high voltage or medium voltage cabling in, and like in this picture here, like all these kinds of like this stuff you hear, like this is just substation. Like this is just substation infrastructure. Like it is a ton of all of the types of power infrastructure necessary to run stuff at this scale. It's massive. So yeah, that's when I mean that they're running out of power, is just you cannot get more infrastructure in the area to get power to the computers.
Do any of the data centers self-generate?
Yes, that is actually, talking about it, like one of the ways some of the data centers in Virginia, they're just building on-site gas turbines. Yeah, like they are either doing that for a permanent generation capacity or until regional grid becomes available. So we are literally at the place like, let's build a 200 megawatt on-site combined cycle gas turbine to run the whole data center.
That's crazy.
What about, I mean, in here, historically, right, there's residential, say, a golf course.
Yeah.
Is that more typical for the new stuff, or is the new stuff going to be out in the boonies? And I'm asking because of the kind of like the environmental impact.
Yeah.
You have houses and people living right next door to a data center, all this grid,
Yeah.
stuff.
In addition to the power, like Loudoun County, like Ashburn, like there's no political organization here against more data center construction, because it is like, in addition to like all of the kind of concerns we're getting at, like people don't want everything around them just giant, like faceless boxes.
Is it just buzzing because you hear?
Yeah, right, yeah. I've been up there and I don't know, my hearing is probably such that I can't hear the frequencies anymore, but yeah, so there is kind of a mix of like where new things are being built. Like a lot of the stuff out in the Midwest is kind of a little bit out there, but also that gets again into the infrastructure problem. Like you need a lot of power. So if you're not already located someplace near substations, near where the grid transmission is, you're building all of that out there. You're building all the power. You might be building piping to get water for cooling out there. You're building all of the fiber plant to connect these things, because you're building a lot of fiber, like to get out there too. Like we haven't talked about that much. Like, I've seen like road work up here, and like the amount of like just fiber running under the roads in Virginia is like, I think somebody said it was like, it would go to the moon and back like several hundred times or something like that. Because it's like, everything is massively redundant. You need a lot of fiber that gets put out there. And we're talking like hundreds and hundreds of strands to interconnect all of these data centers and stuff like that. Thousands, hundreds, like a lot of, it's just like TLDR, it's a shit ton of infrastructure. Yeah.
So is like northern Louisiana, Mississippi, like Arkansas, and the natural gas and everything that's there,
Yeah.
just like no one really caring what happens there, I'm guessing legislatively, is like, is this area going to become more attractive for data centers?
I think it's going to become more attractive, right? Because one thing I haven't talked about a little bit, like there are actual benefits. Like you would think like, oh, you can just put a data center anywhere, but like if that was true, there wouldn't be an AWS West, an AWS East, the AWS Central, all the little different regions. Like there are reasons to like co-locate your stuff. And one of the benefits of like northern Louisiana is you're close enough to Dallas that like your like light time on your fiber in the ground is not that different from like a data center in Dallas. And you also cut a little bit of the distance between like Dallas and Atlanta, which is another hub. So if you've got abundant power, a good source of water for cooling, and a lot of land, and a friendly political environment, that makes it very attractive for that kind of thing. Northern Louisiana actually has something that I don't have a map on here. Like I mentioned, like the fiber underground is important. I don't know if any of you have ever seen the map of like it has become a big political topic recently, like all the fiber under the oceans and those kinds of cables. We have a bunch of terrestrial fiber too. There's a bunch of companies that operate that stuff, and one benefit that we would have over Mississippi or North Mississippi is there are actually already fiber trunks that run from like Shreveport to like the Ruston area before going north. in North Louisiana, which means, again, you're building less infrastructure to connect yourself back to a grid up there. Yeah.
A lot of that fiber is along the interstate, is that right?
Yeah, it's along the interstate. Some of it follows old, really old telecom pipelines and other things like that exist. So some of it's along the interstate, some of it's not. But I forget. I think it's like there's a bunch of companies you've never heard of, like Zayo and stuff like that. Like they run a bunch of that. We lease a lot of fiber from them at GitHub. Things like that. Got everything. Cool. All right. So let's talk a little bit about when it comes to the actual market for data centers. There's kind of three broad things: retail, wholesale, and hyperscalers. Hyperscalers are exactly what they sound like. They are meta. The data center being built in northern Louisiana is a hyperscale data center. It's massive. It's part of a massive network of data centers. All of your big tech companies, they're hyperscalers. This is and nobody tell you I told you this. I think Azure ships something I was on a call with them once. We were talking to them about hardware. They ship something 15,000 racks of computers a quarter or something like that between replacement, in and out cycling, just absurd amounts of computers. So that's when it comes to hyperscalers. Now, the other difference here is retail and wholesale. I know there are some small data centers and stuff out in Lafayette, and every once in a while you hear about a pretty small site out there that's serving relatively small customers. That's really retail. You're talking about small business kinds of things, or even hobbyists of I want a cage with a rack or two in it so I can play with a couple of servers and network gear and spend a couple of $1,000s a year on it. Wholesale is the kind of bigger market of that. It's GitHub is in wholesale data centers. We build our own data centers. We have plenty of things in Azure, but obviously we build our own data centers. If you've heard the term colo or co-location before, that's this entire market right here. So anybody that's got a colo data center or something like that.
Are there still some on Poydras in New Orleans? I mean, this used to be a big location.
I actually don't know if that building is still a data center.
You know which one
I know which one I'm talking about. What used to be
the Enron.
Yeah,
the Enron data center.
Yeah.
Back when 600, 400, whatever it is.
Right. Yeah. It used to have AT&T on it for a while. It's a big gray nondescript building. I have no idea if it's still a data center. I remember there was there was a whole bunch of controversy or stuff trying to get diesel to it during Katrina and things like that. But that would be more retail. I kind of probably even when that was built, this wasn't even a different data centers were such a different kind of thing at the time. So one of the things that I wanted to talk about here with this is getting one of the hyperscalers is cool, and that's great. We'll get some jobs and everything out of it. But if we really want this to take off, what we need to do is leverage any of the infrastructure built to support that kind of project into attracting this. Because this is where your network effect of okay, I am some of the bigger suppliers or other medium-sized businesses, and I want to put a instance of my CDN or some regional piece of my application in a region. That's where they're going to go to. And even the big players will do this. Even in a region where you have a lot of data centers, I was in Equinix data center, just a data center builder, working on GitHub stuff, and literally on the same floor as us down the hall, Microsoft had a cage with 3 rows of cabinets in it. What were they doing with it? I don't know. But they put shit everywhere, all over the time, just to cycle things out to, if anybody's heard compute at the edge, that's a big topic, is getting your compute as close to your customers as you can. And so they'll put stuff anywhere, really, anywhere you can find it. But that's gonna be where the really big network effects would be. This is when we start getting a lot of people who do contracting to service these things, small businesses and other stuff opening up to serve that market. Yeah.
So when you say about attaching to the stuff that the hyperscalers are putting in Meta,
Yeah.
I'm doing a lot on consulting around the edge
Yeah.
with AI, and it's really a good balance. So just building those smaller data centers to handle the edge stuff, and
Yeah.
then
tying that to potentially a family
Right,
of
yeah.
hyperscalers.
Yeah, exactly. So, but like this data center here is where like you're going to train like a big model. Like you're going to train a model here, but once it's trained, then you can deploy that to your edge sites to service customer requests faster. Because like, yeah, you don't want everybody who wants to use the latest, you know, going to a data center in Louisiana somewhere, right? You want them to hit the model wherever they can and get back to you. So yeah, that is like why there are kind of all these, in addition to like being able to attract like these big players because we have land and power, a lot of the smaller secondary market stuff is associated with edge people like getting compute where people need it.
Oh, so like, what's like the radius that you can be within to take advantage of that effect? To get that, like, so like, is it, oh, you would have to be in Shreveport, or like, ooh, maybe Alexandria gets some of that, or maybe even Baton Rouge is still close enough to kind of get into that network impact?
I would
on the
say-
infrastructure they'll build out.
Depending on like what the local market looks like one of the reasons like Northern Virginia is the way it is because you just had all those people already in that area. But like, you know, you're still talking about like within an hour or two of a lot of like from one site to the other. There's like plenty on, you know, north and south of like IAD. So like conceivably, like Alexandria or your Baton Rouge area, like if we started to get like some industry of this going, like they could conceivably start to be in play.
So what's going to be more important for like the networking impact? Is it like availability of resources or the availability of like people and like having like civil society existing where people want to live? So it's like, oh, we have the people here that will like help the industry build out.
It's gonna be a little bit of both of those, right? Because like you can train people up, and like these are generally like you don't like. That's one of the things about this is like I saw like conversation around like, oh, is Meta just getting import all the people to do this? And it's like, no, Meta doesn't employ people to plug things in because it is just basically like plugging things in. Like you get a diagram. It's like there is a me somewhere in Meta that creates a diagram of what gets plugged in, and like I tell somebody else to plug things in. And every once in a while I go there and make sure everything's good.
So I don't
They're not gonna
consider,
rack and stack into it, right?
What was that?
I mean, they're not gonna like rack and stack.
No, they're gonna ship built cabinets. Yeah.
so I don't consider Meta a hyperscaler. I consider them a consumer of this stuff. Is that the
I mean,
main
I
focus?
would consider them a hyperscaler because they build their own data centers.
Okay,
Yeah, like I
but
would.
they don't really sell it.
No, they don't really sell it.
I was wondering if they were changing their business model.
No. I consider them a hyperscaler just because like if you like it's a bit difficult to get everybody's like installed capacity numbers, but like if you like other than like like what their business is, they have like the installed capacity of some of these other guys.
Okay.
Like they build very, very big facilities. They're probably newer to the game, but like what I know is like, you know, those are the four people that when you go to like the open compute conferences and you look at like who's talking about like their hyperscale level infrastructure, those are the guys that I think of. I really think of it as what are you doing with your engineering versus necessarily like what your kind of like your product base is there. Let me see what we got next. Okay, cool. So talking about the wholesale data center stuff, this is something I wanted to talk about here. Like when I talked about like the power availability thing here is these kinds of like these vacancy numbers. Where like, this is actually updated. Earlier this year when we were trying to negotiate data center space, there was like, it was less than 1% availability for the whole region in power. And this has like just been slowly coming up. But one of the other reasons I wanted to talk about this is like, we were talking earlier a bit about like what infrastructure we need here. Like the power numbers to attract a couple of like smaller wholesale data centers are not huge, even in the primary market. Like, you know, we're looking at like Dallas, Fort Worth here is like, they've been building up pretty big, but they're like, they have a pretty low vacancy rate. You can see that they're like, they are not building as much out there because again, they are out of power. It's like, we say we can get like a couple of like, we have 100 megawatts and the resources for it, like that's easy. You could say let's get 2 or 3 people to start building a campus out here. it looks even better if you start looking at like the smaller secondary market. Like, these are numbers that like we can easily like see the advocacy for and like get people in Louisiana to like seriously engage on this idea. Like, especially if we can put 2 gigawatts of power in for Meta, like, this is eminently doable.
So,
I've seen, sorry,
Yeah.
I've seen on the news that, yeah, but who's gonna pay for that infrastructure, that power infrastructure? It's gonna be foisted on the citizens. as
Right.
opposed to-
I don't, that's one thing about I don't actually know, because I know Meta is footing the bill for some of this infrastructure up there, of what they're building, but I know Entergy is also building out there. It's gonna be like, I mean, obviously, like, Meta's gonna pay whatever their power rate and all that kind of stuff is, but yeah, I don't know what those kinds of questions are. So that gets into a, like, yeah, if we're building a lot of this infrastructure and we're not using it to invest in a lot of other things, then like, you do kind of get into like, what are we getting out of this conversation? But,
It's like hosting a Super Bowl.
yeah.
and can you talk a little bit, you said the statement of, it's actually smaller than we think, that like the power footprint that we need is actually smaller than we think.
Yeah.
Can you kind of quantify that and what you were talking about, and like talk about why that, to you, who's been in this world,
Yeah.
that number is actually smaller than, it seems pretty doable.
Yeah, well, it's like, I mean, like, this is, the thing is like, I don't actually know what the numbers are, but like, in a lot of places, like, around here, like, this is probably, like, you probably already have excess grid capacity to this level, right? Like, if you had the rest of the infrastructure, you could start getting data centers built out there if you had somebody who wanted to do it. And you can do a lot with that, right? Like, I mean, you know, for about, 15 megawatts, you can have a whole GitHub. So you can get quite a bit of like business out of that, and like it could be pretty significant business.
Could I ask a question?
Yeah, go ahead.
If you're privy and can share the details, from a GitHub level,
Yeah.
like outside contractors that you send work out,
Mhm.
like how many millions are you talking about?
Definitely 7 digits per year,
Just in the local?
just in the local area. Yeah, somewhere in that range. And that's, that is us, and like, I know like that's just like part of like what we're paying to like the buildings and like just like other contracting groups and stuff like that that service, far more than just us, so. Because like we do this through a lot of like contracting and other things like that, we don't actually have any like direct employees on the ground, in these places, so it's a lot of third party vendors and things like that.
Do you own the data center?
No, and we run them on it. Because like I said, like the power problems were an issue even before AI showed up. Like Virginia was out of power for future data center construction before we even started talking about AI last year. Dallas and Atlanta are also like struggling to keep up with it. Yeah.
When you're done, let's say like, just to your point right there, if you're burning 2 gigawatts worth of natural gas, like the reason they're not burning an extra 2 gigawatts of natural gas in the middle of Dallas, in the middle of DC, is because of like the particulates and the pollution that comes out of that.
Well, yeah.
So what happens to the local economy? Like the people, not the economy, but the people who live there when you dump this much.
I don't know where they're citing the gas turbines for these. But I don't feel particularly, if I was somebody who lived in Ashburn in Virginia, I would not be particularly happy about it because there's a bunch of people are about to put combined cycle gas turbines on site at data centers. I know, Meta, at least to their credit, does invest a lot in trying to do carbon neutral by building renewables elsewhere.
But that doesn't help the people there.
It doesn't help the people there, you're right.
People not know.
I think something that we could do here is if we wanted to have another set of political advocacy is also build more renewables in Louisiana and make those things available. Because prior to this, data center builders actually quite like when they can buy renewable energy directly off the grid, because they like something where they can say, I know how much your power is going to cost for the next 10, 20 years, I will write a contract for that rate right now, which you can't do with fuel power source because of variability of fuel prices. So if you can like get renewable capacity built such that it support this, they will absolutely prefer that over fuel cycle. The reason everybody is building, combined cycle natural gas is because it's cheap and it's fast. You can get it going in 2 years. You can get 2 gigawatts of natural gas going in 2 years versus like, I don't know if you've ever seen what 2 gigawatts of solar panels looks like, but that's a lot of solar panels in land and a lot of other things like that. I think it's a little less than wind turbines, but.
Can you talk a little bit about like, because that seems so, I would love to get into like the what we can do
Yeah.
kind of aspect, and it does seem like, so like renewable energy, can you talk about those kind of contracts that data centers like a little bit more, like what are they looking for, what would turn them on?
They really like being able to offset their emissions in one place with theirs in another. They actually like, Microsoft has complained to us about like several of the colos that we have our data centers in because of the mix of fuel that they use. They take their various climate pledges and all those things fairly seriously, and like do try to offset those things and build renewable capacity when they want to. I feel like Microsoft is like building their own wind farms and solar farms for a while in various places. So that is like I said, like what they're looking for is places where they can, build it. Because like, what was like one of the pieces that came out of the announcement is like they'd already built a solar farm someplace in Richland for this. Yeah, no.
With the, incipient administration, is there any chance that, Elon in that big, huge, supercomputer setup in Memphis is going to be called to task for their combined cycle gas turbines?
I'm sorry, say that again?
Since he set up the big, I guess compute farm for Grok in Memphis, is there any chance that like, the federal government is going to go after them for their combined cycle gas turbines, or is it going to be a state issue?
It's probably going to be a state issue. That is what I would suspect. I think a lot of these things are like more state regulatory industries than they are federal at this point. Like if we wanted to do various federal funding things, it's probably like that for power grid and other upgrades for various grants. But I don't suspect they would do that. But not entirely my area of expertise. Yeah.
Have you seen any or participated in any sort of data center creation where it didn't exist, like there was nothing there, or you always, in your experience, there's always some level of infrastructure there?
There's everywhere that I've worked is somewhere like some level of infrastructure that already existed to some degree, right? I haven't competed or I haven't participated in anything. Because like I said, what we do is like we're dealing in leased space, so we're buildings already existed and things like that. Like we're nowhere near big enough to be building our own buildings or anything like that. And if we were, like the chances are we would be in Virginia and other places.
I'm just trying to figure out, like, general, like, okay, this thing, is it near Monroe or something, for the middle one?
Yeah, it's
Let's say that kicks off something.
Yeah.
Or is that a 10-year horizon before you see any significant impact? What the job level growth, what the level of the economy, will do?
You could get if we like, so let's say like if I think Meta is starting construction very, very soon on this. Let's say we get started on that and like, Equinix or Savvy or QTS, one of the other big wholesale folks, shows up and says like, hey, we want to do this too, and in 6 months they've got some project mostly planned and underway. Because like from their perspective, other than like whatever like regulatory environments, like they've built all these buildings before, they know what needs to go into them.
Have you seen what the constraints I mean, sure, once you pick one constraint, you move somewhere else, but, first is power, then it's, what?
Then it's, the biggest constraint that most people run up to after power immediately is water availability for cooling. That's really like power and water are consistently the two biggest constraints here.
I'm thinking more, I'm sorry,
Yeah,
like, kind of like the economic opportunity for people in the area.
Yeah.
What are the types of small businesses that will have opportunities?
uh,
Because there's a constraint lack of people.
right. So obviously, like in the newer, like I can't say too specifically, but I can speculate that like the new Meta data centers, they, like I said, they're all water cooled, so there's obviously a lot of plumbing that goes associated with that. Again, somebody has to plug all these in. There's a lot of medium volt, like electrical installations and other things like that. Like I know that like all of our data centers have like, you know, specialist electricians and guys that do that kind of stuff. Cabling, all these things, like we have, you know, there's groups that specialize specifically in like doing fiber work. We do binding fibers, installing them underground, trenching, cutting, building between multiple data centers. Those are kind of the big immediate things that come to mind of like the kind of like big three. I mean, there's obviously like HVAC is a thing as well. So those are the immediate things that come to mind over like when we're talking about like other small business or other people around these places we could be hoping to try to get built up around them. No. Yeah.
Have you guys looked at the inevitability of maybe quantum and the reduction on power potential, or?
I've like anticipated this question a little bit, and I'm not an expert in quantum algorithms and things like that. I do know not everything can be made to run in a quantum algorithm, so I have no idea.
Wait, what was the question? I used to work on stuff, so I actually make no answer.
Oh, no, so the question was, I'll have to rephrase it.
It's just the inevitability of quantum, and we're seeing some of the workloads.
Supposed inevitability, sure.
Well, but we're seeing, there are specifically some workloads that do go into some qubits in quantum and the speed at which that's happening. And has anybody done any studies of what that would do to like power and all of that in freeing up some of that power?
There are several kinds of general qubit platforms, among them ion traps, superconducting stuff. The biggest power expenditure for, you know, the superconducting is going to be keeping it super cool. The ion traps, you know, somewhat, but to a lesser extent, it's not going to scale necessarily out to the same as this. And the workloads right now are still kind of, they come up with something and then someone tops it with a classical supercomputer, right? They come up with something and someone tops it with a classical supercomputer. Where they're really going for is kind of simulating, mapping it to physical chemical systems. So, and doing maybe what's called quantum annealing. So, I mean, it may be inevitable in certain like pharma workloads, but like crypto is probably not going to end tomorrow. Like, you know, maybe 50 years from now, but like, you know.
Okay.
Believe me, I have seen several people sidetracked into scam companies, and I mean, like, you know, I would take inevitability with like an asterisk. That's all.
So Michael, I wanted to just kind of pull things in since it's 6:55 and 7:06, 666 is our cutoff. So like going into that question of like what can we do, not in that we have answers right now, but I know you've been passionately thinking about this for a while,
right?
And I'm kind of curious, as someone who's at this vanguard, like, what do you think we should be thinking of, and how can we achieve that, specifically in the framework of from now until 11/11, which is the next NOAI, November 11th, and you know, and then how can a collective group support those questions? And I'm hoping that your vision can inform other conversations that we have, and eventually folks can come to me and say, okay, we have a working group, right? We focus on this, and I say, great, let's meet with this legislator, let's raise this money and move forward in this way.
Right, yeah, so I think like the first things that come to mind, like a little bit like what we've been talking about today are, you know, I think you probably have like, somebody who could answer the question of like, okay, like where do we have like some excess grid capacity? Where do we kind of have like the confluence of like land, water, power, where you could then go to people looking to site more data centers and like be like, hey, Like, we're close to Dallas, we're well positioned to be US Central. Like, we know you've heard of hurricanes before, but those don't affect North Louisiana.
Well,
Just like tell people that this oh yeah, you can do this. And I wish I had more data center contacts and business contacts for that kind of stuff. Unfortunately, I don't. Kind of like broader goals. Like I would really love if we could power a lot of these things with something that are not combined cycle natural gas plants. Like continuing to advocate for let's build more solar, let's build wind, let's get the transmission grids, fortified and upgrade to move power to the places that we want them. Which again kind of links back into this idea of all right, I know we have the availability of land, we probably have some of the availability of power before we even expand grid generation capacity. Where is the confluence of those things, and let's start seeing if we can sell that to people and get them on board and get projects off the ground. Or at least get people interested in talking about them.
Just ask you a question.
Yeah.
Sorry. Just, I'm wondering what your sense is in terms of this wave of data center investments that we're seeing.
Yeah.
Are they sort of trying to catch up with the demand, or are they prospective investments in the expectation that these AIs are going to be there?
So it's both. Like I was talking about earlier, even before AI came to the scene, we already were seeing a lot of data center growth, just from the big cloud providers, expanding their various footprints in different places with, 100 megawatt size bucket data center facilities. I think for a while, I think the biggest Azure campus didn't get bigger than 400 megawatts or something like that. So there was a lot of that earlier, and that's still continuing. We all, everybody in this room is aware that we're all consuming, everybody is making new apps and new businesses and consuming more and more cloud computing everywhere. I would be surprised if somebody has not, if you were trying to get AWS capacity in some places in the last year, you may have gotten told no because of various cloud relations. But a lot of this stuff, what Meta is doing here, this is the kind of speculative investment on all right, we see these things with AI, we think we can do something like this, I am almost certain, based on what they put publicly and what I've heard elsewhere, is this is part of this specific data center here in Richland is going to be a site where they will train one of the next gigantic large language models or whatever the next kind of model we're talking about after that might be.
So, to have the northern Louisiana or this region be considered a critical mass,
Yeah.
how much more do you think has to be built out? Do we need to have Google or Microsoft come and say, hey, Microsoft's hey, we're gonna match Meta and we're gonna build out the next training data center for OpenAI?
I think I don't they might fall in the area now that Meta has done it, they might just be oh, okay, there's clearly interest in there and maybe they'll follow along. One of the other things, if we can get some of the wholesalers out there, is they will start putting small things in those meetings.
So
Yeah.
are you familiar with the one that's allegedly going in West Louisiana also? I think.
No, this one I'm not.
I think it was called Hunt 8. I think it was 300 megawatts.
Okay.
And so that's in between Baton Rouge and Richland right there.
Yeah.
Just north of that.
Okay.
So that's another one that was announced a couple days after the Meta announcement.
Do you know who's? I missed that announcement.
It's a crypto thing called Hunt 8. I think they have 19 sites, is what I read. And
Okay.
this is going to be one of them.
Okay.
And a lot of them are in New York and Texas and Alberta.
Oh yeah, I wonder if they're the ones in Texas that when they were having power problems, they paid them to not mine. Yes.
When these data centers are installed, how long does a server run before it's considered out of date? They leave it in place for 5 years, no, it's 2 years, we're swapping it out.
It used to be 2 years, but it used to be a 2 to 3 year life cycle on these. Regular compute and storage stuff now is getting to depreciation times of 5 years in some cases. Like, we have servers that old running at GitHub, and like they're slated to at least do another year of service before they are fully deprecated and replaced.
Is there a secondary market for these?
Yes, there
Like,
is.
okay.
Yeah.
Inference. Like today's training is tomorrow's inference compute, because
Right.
you need like much larger for the training, and so once that kind of gets aged out, you can, as I understand it, you can reuse that same, like,
Mhm.
okay, now we're gonna run inference,
Yeah,
which is like after
they
training.
they also get sold like just on like a secondary market and stuff like that and get repurposed.
Just secondhand each one.
Yeah, just like, yeah, you can go find, you know, any blade that survives the process and is still functional, you can find ultra cheap, refurbished, like 2 or 3 generation
So
ago
like
blades
in
online.
Virginia, are there some like first tier providers who always get to do the creative stuff, and some second tier, they're like, we'll take your cast off, your leftover, and we'll run second generation stuff, and it's cheaper.
Yeah, there are definitely groups that do that, especially like all the like, I know there's like plenty of like the budget clouds and like folks doing those kinds of like
Still
operations.
around? I mean, are they like spinning stuff off?
Rackspace is still around, I don't know how much they're spinning up there lately, they're one that I don't hear a lot through the grapevine about, but,
Would you expect a second generation set of facilities to happen here in Louisiana?
if we got a couple of like wholesalers and other things like that, like because those kind of second generation facilities, like they're not building their own data centers, but they are gonna like, you know, they're gonna open a cage in a colo or something like that, or refurbish servers and sell them. A lot of them they end up in like education and like nonprofit spaces and stuff like that. Like I know when we decommissioned our like, gosh, they would have been like, you know, 5 or 6 year old Dell servers by the time we got rid of them, but we decommissioned them and we gave them to a service that like spins them off and gives them to nonprofits and things like that. You know, after we you know blanked everything on them cryptographically and shredded drives, but yeah.
Are there any initiatives, plans, or even murmurs about like access for academia institutions here in Louisiana?
I haven't heard anything like that. I don't like. Meta has been historically like they've been. I think they've, especially with like the AI stuff, they've just been like, here's our model, let's throw it out there. If you can run it, you can run it. But yeah, I don't know anything specifically. I could ask. I have some contacts I can ask about it and see.
There were some noises at Tulane that Mark Wheeler in the video like threw a bunch of money at them, but from what I hear internally at Tulane, the actual implementation and spending of that money was not happening.
Yeah, no. I
The
know.
releases it, yes.
Yeah, I know NVIDIA announced some new edge AI device like yesterday or today, and I haven't looked at the specifics of it yet.
Oh, I saw that on there.
Cool. Well, thank you so much for leading this. And hopefully what you've led is like a talk that leads to a working group.
Yeah.
And so, like, I would love if you want to do something weekly, monthly, every now and then, whatever it is, we could do it. We have this space, we have various other spaces. I think we have philosopher Florins I can throw at it. Different political connects, whatever it is. But you're definitely someone that I look to like help lead this.
No, absolutely. I'd love to be. I'm happy this happened and we can make this connection because, like I said, I've been thinking about some of this stuff for a while.
Yeah, and I think that I mean, in my reading of the tea leaves of folks who are now running things like Josh at LED.
Yeah.
There's people who will actually listen to folks who are experts in fields, which hasn't necessarily been the status before. So I'm really very much hoping that that we can continue this. So I mean, I guess is the best way to people just get in touch with you is to find you and
Yeah, find me. I'm obviously like I'm in the NOLA Dev Slack. ADR Mike I think I'm Michael McCoy. I don't know if I'm ADR Mike on there again, but like I'm ADR Mike at GitHub. You can email me, find me on LinkedIn. Grab me after here. I'm happy to give you my number if you want to chat about stuff. So
yeah, and I would love to like keep things going. So the best,
absolutely.
Like the one lesson that I've learned in my years of doing random stuff is to have a regular thing, whatever it is, specifically at a weird time, usually leads to some kind of action. Anybody can get in touch with me by doing this QR code. And again, I remind you that we're raising money for work to buy students at Warren Easton AI stuff. So all of your potential to these areas will go to that. Thank you so much.
Yeah.
Yeah, where we can